Good morning, good afternoon, and in some cases, good evening. My name is Bill Smith, and I'm the Vice President of Sales of Bradmark Technologies. I want to welcome you, everyone here, to the SAP ASE Encryption webinar presented by Peter Thawley. Most of you know Peter, but for those of you that don't, he is the Vice President and Chief Technology Advisor, ASE Engineering, HANA, and Database Technologies for SAP globally. Our experience is that Peter is the expert where it comes to ASE and ASE encryption. So we are proud that we were able to get him for this WebEx. We're all anxious to get ready for Peter to get started, but real quick, let me tell you about Bradmark. Bradmark has been in the database tool space for the last 30 years. Our flagship product is Surveillance, a database management and monitoring tool. For the last 10 years, we've been a Sybase partner, and we're the only Sybase database monitoring tool recommended and sold by Sybase. Our customers comprise 550 of the Fortune 100 and 380 of the Fortune 500. But some of our customers are as small as one server. And I say that so you know, our customers run the full gamut of products. Okay, we have three lines of business. Database monitoring. We develop tools in-house for monitoring and management database. Our target customer, our target database is Sybase, IQ ASE Rep Server HANA. However, we also do all the other popular databases too. As an example, Microsoft SQL, Oracle, DB2. We're also a database and technology reseller, and that's why we're here today. When we talk to customers about SAP licenses for database, we've been hearing a lot of questions about encryption and security. So we put this together. Now, this year, last year, and the year before, we were the #1 reseller of database and technology products for SAP in North America. Now, our third line of business is professional services, and we do the services for all the other products we sell. So all the SAP products we sell, we do the services for, and all the monitoring tools we develop, we can do services for them too. So we can come and install, train, we can document, we can tune, we can come in and manage your system for you end to end. So those are our three lines of business. And now, without further ado, I will turn the meeting over to Peter Thawley. Peter?
Thank you, Bill and John. Really appreciate the opportunity to come here and talk a little bit about a topic that is, quite important these days. You certainly hear a lot of information in the press and in the industry about security. So we're going to talk a little bit today about all sorts of different topics. We're going to start by talking about, kind of the authentication and how the network interactions play with respect to database security. We're going to talk a little bit about security policies and the importance of tying security policies into your application frameworks. And then finally, we're going to talk about an area of innovation at SAP recently, specifically around encryption. And then we'll wrap it up with some best practices. So first of all, I'd like to kind of start out by saying really that no matter how good an intent and how good technology can be in helping us all resolve and protect our systems from, bad people, poor business practices can defeat all of that, right? An example here was a company called ChoicePoint was exploited basically because their business systems allowed a bad person to come in and establish what was effectively perceived to be a legitimate corporate identity. And of course, in that context, they established a certain amount of trust. And when that happens, no matter how good the technologies are that sit behind them, that entity is perceived to be a valid entity. So, it is absolutely critical for us to enable security by both a combination of strong technologies as well as strong, proper business processes that go with that. The other salient point here is really that proprietary theft of information in many cases is done by insiders, people inside the company who, for one reason or another, feel compelled to either take information and use it for some ill-gotten gain. So again, these are often people who have legitimate business reasons for being there, and this is one of the reasons why technology is just one part of it. Strong business policy we've talked about, strong auditing controls, are also a key aspect to maintaining the integrity of the systems that we all are entrusted with. So let's talk a little bit about the landscape, right? The security landscape. In many cases, especially in the last 10 to 12 years, government or industry regulation has driven a lot of requirements that both all of you and us as vendors are responsible for implementing. You can see the list here, which is really just a partial list of regulations that have now been imposed on us all, including payment card, PCI, data security standards, the HIPAA healthcare standards, you name it. There's a boatload of regulation that has all of us probably working more hours than we care to. Unfortunately, despite all of the good intent of both the policy and lawmakers, as well as the vendors who are charged to implement many of these things, there's been a huge amount of breaches. Really, in the last 2.5 to 3 years, this example that you see was from a Verizon study that looked at data breaches. And so despite all of the regulations, despite all of the money that end users are spending on security and corporations are spending on security, we still had in 2012 some 47,000 reported incidents, and 621 of those involved data breaches, right? And if you look on the right side of your chart there, you'll see some somewhat staggering statistics, right? As you might expect, a majority were driven by financial motives, but what may not be so obvious is that a lot of them targeted end-user devices, so mobile devices in particular. A lot of them involved compromised servers, so hardware or software systems that sit behind firewalls typically. Most of them were discovered, really almost over 2/3 were discovered by people outside of the corporate entity that was actually breached. So some staggering data to tell us that, despite, again, all of the great intentions, all of us are probably not doing a great job when it comes to securing our systems. So as we start to think about the problem of security, I think the important first point to make is that this is not just one thing. There's no single switch that you can flip on that will protect us from all, hackers and black hats, as you call them. But rather, there's a series of layers that need to be each protected using most likely different technologies, different approaches, And if we just look at the database itself, right, we see there are a variety of capabilities that ring fence, hopefully, the data that we are charged and have some fiduciary responsibility to keep safe, right? So data privacy, which is really what we think about when we talk encryption, is really at the center of all of this, right? Kind of the last line of defense. And around it, we have things like row-level access to be able to distinguish between different users' authorizations to see different kinds of data, right? We have the more traditional discretionary access controls, right? These are the permissions that you apply to different roles, right? We have user security, the typical username, password, or single sign-in authentication, via Active Directory or via LDAP or something like that. And then, of course, around the edges are the physical aspects of network security, right? And so we're going to talk about a number of the areas that really are very critical as we start to think about this. So let's start at the outer layers and talk about the network security. So for years, the ASE product has had effectively transport level security, right? We've implemented secure socket implementation so that client applications or middle tier app servers can connect and encrypt the network layer. We've had Kerberos for a number of years. Of course, we've got our user authentication, and we've got some things around login controls that I want to spend a moment talking about, which are not as broadly adopted as I think we would have expected, right? So what's the problem that we're trying to solve with transport security? Well, if you go out onto any open source site, packet sniffing software, Wireshark is a good example, is readily available, right? Most people, most hackers, I should say, can easily find ports and what port numbers are traditionally used for various database engines, right? The problem that we're trying to solve here is both data going in as well as data coming out, right? So encrypting the network transmission, whether it's SSL or some other capability, is really very important. Web servers, especially those outside the firewall, have long used HTTPS and other technologies to be able to incorporate network-level encryption. Corporate users have long had VPN, virtual private networks, to be able to access corporate data, right? And those are just really two examples. So with ASE, again, probably, I can't remember precisely, it was probably added in 12.0 or 12.5 maybe, a long time, but we use SSL certificates, and our implementation builds on libraries. Actually, this slide is a tad old and I didn't catch it. I apologize. We don't anymore use Certicom. We now use OpenSSL as our encryption library. In the future, we are likely actually going to change that. SAP has some very strong security credentials and actually has their own libraries for doing various things. So these libraries tend to use very advanced encryption technologies, right? Strong algorithms, as well as other algorithms slightly weaker because of performance considerations to deal with, authentication and message tampering, right? And these are implemented, again, apologies, this is a slightly old slide, really across all of our API interfaces, right? ODBC, JDBC, client library, for those of you writing in 3GLs. And the model is quite simple, right? It's just like HTTPS, right? A little bit of handshaking, some certificate exchanges back and forth during that. And that operates, whether it's a client application making the connection or if you're doing server-to-server based communication as well. Implementing SSL, it's fairly standard. Most people understand this. Get certificates, create a trusted roots file, enable it on the server, add some SSL ports, and then restart the server. So it's fairly painless to implement this. Obviously, nothing is free, right? So from a performance perspective, certainly there is an overhead to doing that. But with today's technology, especially next generation servers that have been really out for a number of years now, where hardware acceleration right at the network layer, right, either on the network cards themselves or actually on CPU itself, has really made that overhead almost negligible now. Again, new generation hardware is overcoming a lot of the excuses, right, that a lot of us had for not implementing some of these things. Is SSL always necessary for databases? I think we all have to use our best judgment, right? It depends, as always, right? If you're accessing, from my laptop to a system, and I'm already running VPN to be able to access other corporate assets in my company, then probably not. Oftentimes, internal employees are accessing data that's really not sensitive. Portals are good examples, right? Documents or things that may or may not really be important. Oftentimes there's a layered effect of these systems in front, each with authentication. So oftentimes, as in the bottom example, customers don't have direct access to the database. They go through a series of systems where authentication and authorizations are perhaps implemented, all using oftentimes HTTPS as their basic technology here. So if we move a little bit, I want to spend a moment just talking about passwords, because clearly passwords are the bane of all of our existence. And it's not that the password is so bad, it's remembering the password that's so bad. Our passwords, as most know, are been around forever. We use login names and password associations. We encrypt. There are ways that you can ensure encryption happens, both in really in all of our interfaces. But password policies become an important part of database security now, right? Making sure that they're strong passwords, right? That there's some complexity to them, that they're not simple common phrases, or that you use things over and over again. We also support login failures, right? Which are a very important line of defense, because generating random passwords or trying to guess things is something that a lot of hackers have tools and toolkits to use, right? So this is an example really of all of the complexity capabilities that are in our passwords. I'm not going to go through all of them. Kerberos is a technology that has not seen a lot of adoption. In fact, some vendors, Microsoft, for example, took Kerberos and changed it slightly to become Active Directory's security model. So the technology is quite mature. It uses symmetric encryption with keys obtained from a trusted source. It provides authentication directly together with transport security, and provides all the key management. This is a technology we've supported now for many, many years. This slide really just gives you the steps that we go through when authenticating using Kerberos models. It looks very similar to what an Active Directory authentication model tends to look like. Because Sybase grew up in the old days in a lot of banks and a lot of public sector, especially the intelligence community kinds of environments, we also had a facility to allow people to plug in their own authentication modules, which became important in a lot of government and some financial institutions. Okay. What is most common in terms of single sign-on technology is LDAP and Active Directory, right? So users still provide passwords, but rather than authenticating it directly in ASE, we forward it to an LDAP instance for authentication. So that provides, obviously, single sign-on centralized password management. Centralized password management is really an important key tool to protecting all of an enterprise's data assets. Obviously, if an employee who is not tremendously happy decides they want to steal some stuff, being able to revoke all access to all systems with one centralized environment becomes quite clear, quite important. Today, our LDAP and Active Directory support is really focused on providing directory service, so server location, as well as authentication. We haven't gone the final mile in that implementation yet to support roles within LDAP. That's something that I know we're starting to get a lot of interest in our larger customers to do. Again, this looks very similar to what the Kerberos implementation is, but it's a multi hop handshake that has to go back and forth between the client or the application server tier out to the LDAP server and back, and then provide authenticated tokens so that ASE doesn't get spoofed here. There is an interesting problem in our sort of modern day application design patterns, right? Everybody's using application servers, middle tier technologies, whether they're open source like JBoss or whether they're commercial offerings from IBM, WebSphere, or the old BEA WebLogic product. But that common problem is that everybody wants to use connection pooling in order to be able to maintain very high performance interactions, right, between the database and the ultimate end user. So this connection pooling implies that you log into the connection, the app server logs into the database using most likely a generic system kind of identifier, login password combination. And so one of the common challenges is around ensuring that work done on behalf of a particular user can be audited or can be tracked somehow using the actual identity of the person doing the work, not the generic login, right? So many years ago, I can't remember, I think it was around 12.0, we added this idea of proxy authorizations or session authorizations, which allows existing open sockets, open connections to the database to assume the identity of different users at different times. So that way you can grab a connection from a pool of free connections. You can set a context for the identity of the user that connection is about to do some work for, and then do that work. So if you're using auditing solutions, whether they're from us or somebody else, all of the auditing and access control lists that you might be using in the database can be properly enforced, right? So very useful technique that, frankly, a lot of customers don't seem to know. Also, another area that is quite interesting in the general sense is this idea of a login trigger, right? And a lot of this is, you might want the ability to let's see, you might want the ability to set some information, maybe to verify that the application that they're connecting to the database from is one of, an approved application, perhaps. You might want to check IP addresses, host IP addresses, things like that, to see if, maybe the subnet that they're coming in from is not one that they should be coming in from. So this notion of a login trigger can be quite powerful to set very application-specific contexts that can then be checked on the server side, whether it's in login triggers or even in store procedures or more lower-level access code that you might have written here. So a common, sort of thing when we talk about this is broad enterprise security policies, right? Marketers, should see information at one level, but maybe not necessarily very detailed customer data. Sales reps shouldn't be able to see information about other sales reps, customers, right? Different apps might have different privileges, external people, external customers, partners. This becomes, quite important, especially as we start thinking about, broader hybrid kind of cloud operations. And so we've had a number of techniques over the years, from roles to something called application context facilities, fine-grained access controls, and the login triggers that I spoke about to be able to implement these things. Roles are quite powerful, right? You can enable certain parts of roles and add exclusivity for different operations to different classes of users who have different roles. So a very powerful capability. Key to that are some things that you can add to your code to be able to test roles directly in many of the applications that you're writing today. So in the old days, 12.5 or so, we had this proc role that's been kind of, I wouldn't say deprecated, but we have a new role in 15.0. It's not new now, I guess. Called has role, but all of these are things that you should be, thinking about, right? So DBAs, although they're quite familiar with granting discretionary access, grant insert permission on a particular table to a particular role, however, using these, has role or proc role really allows you to be much more aggressive in implementing security policies within the different application layers. Practically speaking, although there's a much higher theoretical limit, I think most of our customer implementations and testing and benchmarking and things have sort of, made us realize that we have an effective limit of around 900 to 1,000 roles that can be active, just in terms of consuming memory, consuming procedure cache, and things like that, right? So if you aren't using roles quite extensively, please do rethink some of that. Very important. Application context basically lets us set information about the context of an application usage, and that context is retained through the life of the session. So it really allows us to build highly trusted applications that we can incorporate or use it with other techniques in ASE like fine-grained access control. Very useful technique. If you haven't started looking at this and you're worried about the concept of trusted applications, please take a look at some of the information around ACF and login triggers and things like this. So you can set really, anything you want as a context within your applications, and it's only visible, to code that lives in the server, so in the database server. So most people tend to use this in conjunction with login triggers so that you can set things and keep it confined to the database level, not have a lot of stuff going back and forth across the network. Row-level access control, fine-grained access, so this is really row-level permissions. And is it still necessary? Well, it's possibly necessary, right? SQL permissions operate, pretty much at a table or column level. Data encryption and decryption, it should say, really tend to be at the server level, the database level, or at individual column levels. So rogue users, especially ones that are insiders, can still potentially have some access. So you have to again be a little bit more careful. And this is big in like the EU, right, where there's very strict privacy laws about who can see what and what information can be hosted outside the country of origin, all sorts of things. So these sort of fine-grained access controls, so ASE and Oracle both have techniques for doing this. Again, quite a powerful capability. So just some examples here of how you might use it. And using these things in conjunction with each other, right? Fine-grained access plus application context really combine to make very secure, highly trusted, kinds of programs. I'm going to skip that a little bit. We've, I think, talked about most of those, in great detail. So let's move now into kind of the meat of the discussion around encryption, right? So first of all, you have to ask yourself, is encryption necessary, right? Now, first of all, our first inclination is to say possibly not. There are lots of those regulations we saw earlier, but like a lot of laws, they don't go quite far enough. And in many cases, these regulations exclude certain types of systems, right? And so for that reason, you have to ask yourself not is it necessary per se, but what's the risk, right? The second issue that, we should all be at least aware of is performance, right? Again, nothing's free, no free lunch. And the operation of encryption and decryption is a CPU-intensive activity, right? In both column-level implementations or database-level implementations, these operations take CPU. They often expand the size of the storage, and they take time, right? Now, of course, as we said earlier, the advent of newer hardware techniques where they've pushed things like encryption and decryption, in some cases, all the way into the CPU, has made that performance impact much less. And of course, you add to that the fact that some of these, commodity servers from HP or Dell or Cisco or whoever, Intel-based ones in particular, are really pushing what used to be mission-critical, techniques and technologies that were only available on the high-end, Unix platforms into the mainstream, into the commodity levels now. But, again, you got to be at least aware. And, of course, our column-level encryption, although, when we first implemented this in 12.5.4 or 12.5.3a, we were quite proud of our column level encryption, right? Our computer science perfectionism, made us believe that that not all data needs to be encrypted, right? You need to encrypt, credit cards, social security numbers. You need to encrypt certain things. But in reality, as people started to use this, we realized quite quickly that if the searchable elements, the SARGs as we call them, search arguments, are things that need to be encrypted, then basically encryption really kills the system, right? Because oftentimes you're going to get table scans, plus you're going to have to do decryption, right? So you got to think about that. And lastly, I mean, let's be real, right? All of us have, in our own companies, have some fiduciary responsibility here, right? The company is liable, right? As we've seen from all sorts of different, I'm not going to name names, but we all know, we see them or read about them, right? And I think about this, I call it the New York Times effect, right? Hacking is easy. Hacking is very profitable. And, you do it from your basement, right? So you don't even have to go out. Now we've got, unfortunately, state-sponsored projects, right? Thirdly, relying on contractual responsibility. I mean, that's going to help, right? At some level, right? If you get hacked, okay, well, or if you trust your backups to a certain partner and they don't keep them safe, then okay, yeah, you could sue that entity. But you know something? When your company's name is on the front page and your customers have lost trust in you, it's not going to help your business, right? So first of all, let's talk about the different tiers. Where should you encrypt, right? A lot of people encrypt in the client or the application tier. They use their own crypto APIs. Data stays encrypted in all tiers, so that's a benefit, right? The app dev guy chooses what to encrypt or not encrypt. But the disadvantage is that, they have to manage the keys now. Key management becomes the application's responsibility, right? It's a lot of work and perhaps a lot less secure than encrypting in the database server, right? Encrypting inside the database, we have much more intimate knowledge of data, right? And it becomes yet another data security service that goes along with authentication, access control, auditing, right? So the database encryption allows us to be more stringent, right? Better implementations. And unlike column level encryption, database level encryption means that we can still optimize search arguments that are encrypted, right? Apps are simplified, and of course the implementation provides protection for data at rest at all times. So a pretty key capability. Lots of different algorithms. Obviously, we tend to use AES, which is generally the most secure. Very long key lengths. We tend to use asymmetric keys, so shared keys, for various things that are very performance sensitive, especially around connections and things like that. We talked about that. So interesting kind of test here, right? Even if a data is encrypted, in certain cases, the cardinality of the data or other elements of the data could help hackers understand the data, right? So you look here, right? If you ask the question, who's colorblind, right? By just looking at all these status data, it's a little hard to tell, but if you really look hard, you'll see that the values in yellow are the same, and all the other values are the same, of a different value. So it's pretty easy to sort of say to yourself, okay, color blindness is fairly rare, so I can infer now that Sam and Wally are colorblind because they have the same encrypted ciphertext, right? So We tend to use things in security called initialization vectors. They modify the behavior by, effectively adding what we call salt. Oops. Salt is sort of this random thing, not quite random, but almost, that changes the cipher slightly so that even though they're the same value, then the same clear text value, they actually convert to something different. Key management, again, becomes easier in the database. Application transparency, we've talked about that. So let's talk a little bit about the main opportunities, right, in ASE to use encryption. So as we indicated in 12.5.4 and later, we did column level encryption, right? Same sort of core technology, right? Same key model, encrypted key model, same sorts of things for the most part. And it basically allows you to be very selective. And so what you see is that where we do encryption and decryption is different in sort of the stack of operations that databases need to perform. So in column level encryption, the encrypt and decrypt operation really are after optimization and just before we send result sets back to the clients, right? So the benefit really is you only have to take the performance overhead for a very small subset of data, and that's positive. The bad side, the downside is optimization sometimes makes the wrong decisions if you're searching on an encrypted search column, right? So what we're finding now, especially with some of the newer hardware, with some of the new technologies that are now embedded inside the Intel Xeon chips and things, that maybe all of that is really not all that important anymore. It might be better, right? It might look better if everything is encrypted all the time, right? And so that's what we did in ASE 16. I will admit, one of the driving factors for our decision to do this was cloud, right? Cloud operations. We are seeing quite a few people, quite a few systems that are implementing things in, not just public clouds, but even hybrid kinds of clouds, where the risk is too significant. And having a encrypt everything model really helps, right? And so that was really a lot of the motivation, right? Pretty much everything now is encrypted. All data, all indexes, transaction logs, is encrypted. When we back it up, it's backed up in an encrypted form, right? So you don't, in this environment now, you wouldn't have to take a backup dump that might have been done through backup server and then encrypt it using external sort of third-party tools, right? And as we talked about, because encryption and decryption happens between the I/O layers in ASE and potentially the compression or the query processing layers above it, a lot of the performance issues we had with bad query plans go away entirely, right? So generally speaking, we're seeing a lot more interest, especially given the regulatory and general paranoia we see in the industry around security. So some key points. We talked about the optimizer being able to function intelligently again. You can encrypt and decrypt a database at any time, right? It's an online operation. we do this in parallel, so we'll spawn multiple threads to be able to operate on different devices in parallel. You can suspend it, so in other words, you can alter a table, you can encrypt it during the sort of low times in your workload, maybe at night or something, and then before the trading day opens or before the morning kicks off, you can suspend the encryption and then resume it later on. So it's very easy to do this in a way that kind of fits within either maintenance windows or just your the ebb and flow of your workload, right? So you create encryption keys, right? You can specify key lengths. You can have dual controls. So in other words, to be able to encrypt or decrypt, you need 2 passwords. Not used extensively, but in some scenarios, very critical to have sort of dual custody kinds of models, right? So, and it's simple, right? A person with the right authority, right? Site security people generally create encryption keys, and then people writing code in stored procedures or on the application side or whatever are able really just to use the key. They have no idea what the key is. So very useful way to sort of separate out things. And security people, really the hardcore guys and gals, they harp on separating the roles, right, and having key management handled by one set of people and key usage, right, being handled by the developer kind of folks, right? If you look at sort of the technology underneath it, right, this is really what happens, right? Data becomes encrypted just before it's written to disk and right after it's loaded into memory from the I/O, right? We don't touch header and offset table stuff, and we have a page status bit that basically indicates whether the page is encrypted, and that's what enables us to do this thing sort of online, so that as you encrypt the database, it can be in kind of a middle state, right? Some of it could be encrypted, some of it could not be encrypted. This is a technique that is very useful and follows a lot of the same technology we did in our data compression. Follows a similar model where some pages can be compressed, some pages could not be compressed, and the runtime engine is able to figure it out very simply, right? There are some things we don't encrypt, allocation pages, GAN pages, things like that. Those are things that are system data, so we don't really need to encrypt those. And we use standard algorithms, right, to do this, right? We also use this initialization vector technique to add even more security into this model. Okay? This is our parallelism. I kind of mentioned it quickly. Here's some details on kind of how that works. I'm going to skip it so that we can make sure we save some time for questions. A couple final things, and then we'll wrap up at least my piece. We also found that just like some operating systems, when you delete a file, it doesn't actually delete the data. It just simply makes it invisible, right? Same is kind of true with deleting data in databases. You have to be conscious of, if you're going to literally zero out or wipe data as part of a transaction, to really clear it out, that would probably bog down most transactions. And so you don't want to do that necessarily as a matter of course. But we did add a secure data wipe in 16 that allows you a more granular level. There might be some data that you want to securely wipe, basically reinitialize or zero out at a transaction-by-transaction basis. So when you're dealing with credit cards, for example, that might be one thing you'd want to do anyway, just as yet another level of security here. Right? We also added quite extensive capabilities around auditing. And this is an area that I think you're going to see us invest a lot more into. There are third-party products, very excellent third-party products that do some level of auditing, but again, having it tied into the database seems to be an expectation a lot of customers have, and also is a much more secure way to do that. So we're doing a lot more auditing of the full text of information. Again, you would probably combine this with encryption of the audit database to be able to really lock down and make this a highly secure kind of environment. We've also done some things in our auditing around configuration changes. Believe it or not, some people, even insiders, might want to kind of ruin your configuration to cause not necessarily data problems, right, but to cause other problems, right? So we lock down configurations now with that. So a couple last comments around best practices. Obviously, if you're thinking about column level, you really have to decide which columns you need to worry about. Choose your keys wisely, and don't be don't be worried about having too many keys. Using multiple keys to do different kinds of data is often another excellent way to to create a highly secure thing. Separate keys and data. Don't put them in the same place, right? You don't have the fox guarding the henhouse, right? And manage those. If you do a centralized key management, which is not a bad idea, manage the backups of those databases very carefully. And change keys, just like you have to change passwords periodically. Changing keys can be, another good technique, right? Keep data encrypted during movement, right? Rep server, bulk loads, right? Things like that. Use SSL, but the overhead is really fairly minimal now. And we've talked about performance, right? So I'm going to skip a bunch of these things. And then finally, don't forget about disaster recovery, right? If you have a key management database, make sure that you're replicating your key management database over to the DR site too, right? Because nothing would be worse than having to fail over to a DR site, but then not be able to actually access the database because somehow you've lost the keys, right? So the last thing I want to say here is, and again, thank the Bradmark crew for inviting me to come chat with you about this topic. As many of you know, I'm a big fan of the surveillance tool. I think it's a great tool. I just wanted to make sure that you were aware that the surveillance tool does quite a bit of monitoring of things that are relevant to the security topic, right? They can, allow you to see whether databases are encrypted and what state they're in, right? They have interfaces into auditing, right? So you can see the log usage windows, right? And you can see statements and things like that to supplement auditing. So all of the things that we've talked about really are generally supported in different ways by the surveillance product. And so with that, I think I'll thank you for your time and turn it over to Bill. Maybe do some final Q&A. Bill, you there? You might be on mute, my friend.
I was on mute. Thank you, Peter. Hey, on behalf of everybody at Bradmark and just in general, on behalf of everybody, thank you, Peter. That was great. I learned a lot from it. There is one comment I'd like to add, and that is we have a lot of companies that call us wanting encryption, and they have earlier versions of SAP ASE 16. In ASE 16, it's very simple to implement encryption. So if you're on a 15.x or a 12.x or something that's not 16, it may be a good idea to upgrade to 16 and then implement encryption. So we want to help you do that if we can. There's no written questions right now. So if anybody wants to ask a question, can you open the mic?
You can post. Let's go ahead and post any questions you might have. There are a couple of questions we can speak to right now. One was brought in about data security concerns. How they hold back? Do they typically hold back companies from embracing the cloud? Peter,
I think Peter answered that one.
Did you?
Yeah, you talked about.
Well,
that.
I think so. I mean, just I know I mentioned the cloud in general, but security, and at least in the people that I've talked to, security has been one of the factors holding people back from cloud adoption. I think that's one of the reasons why full database security becomes an important thing, right? We don't have to worry about anything, even in public clouds like AWS. So, definitely.
Okay, well, so we do have a question from Laurent Perotti. And John, would you read the question, please?
What about cross-database, was that X?
Exact,
yeah.
With an encrypted and an unencrypted
database. Very good.
Yeah, so, cross-database transactions, it's a good question, first of all, because, and a lot of it's going to depend if you're using columnar level or database level, but at the end of the day, each database or specific columns in a database have their own keys. So, because a lot of this stuff happens in layers that are independent of transaction logging, it's somewhat irrelevant. It does mean if you're doing a cross-database transaction that part of the transaction and the transaction log records are encrypted using one key, and the other transaction in the other database will use a different key. But there's no additional concern over that, really.
So Lucy Curaz would like to ask how replication performance is in encrypted data.
Replication, has, techniques. So when we replicate, we would expect that you would use probably an SSL implementation between the rep agent and the rep server, so it stays, encrypted there. Similarly, when the DSI thread needs to replicate, into the target, that you would also use both HTTPS and that on the target side, one would expect that the target databases would be encrypted as well. I'll have to double check. I'm not 100% sure if I know the answer to how data is stored, like in stable queues, if it's encrypted there or not. So that's something I will research. I'll provide some feedback to the Bradmark teams, and then when they probably send out the slide decks and all that kind of stuff, maybe Bill and John, maybe we can just add that answer in there when I get it to you.
Sure.
Sounds great.
Now Monica Liu asks, if we dump the rep server queue for troubleshooting, how can we see the transaction details?
Yeah, again, I'm not a huge rep server person, so I apologize. I just don't know the answer to that. So I think, that'll be part of the feedback I can.
Yeah, and it doesn't matter because we know Laurent, Lucy, and Monica, and so as soon as we get information, we'll provide it to them. We know them already. And so in closing, we'd like to ask you guys to join our social network. And if you have any further questions, you can contact us at sales@bradmark.com or just call us at 800-621-2808. Thank you very much for your time. John, I'm going to turn it over to you.
All right, guys. Well, thank you so much again, guys. Thank you so much, Peter, for your
Thank you.
Wonderful advice. And we are going to close this session today, and we hope to see you guys soon at another very useful event. Exactly. Take care, guys. Thank you.